We want to evaluate the given double integral. First, notice how the region of integration is from x equals 0 to 1 and y equals 0 to 1, which means the region of integration in the xy plane would be this square region here, again from x equals 0 to 1 to y equals 0 to 1, giving us this square in the xy plane. Next, notice how the integrand function would be non-negative over this region, which means the double integral is equal to the volume below the surface and above the xy plane over this region. Let's look at this graphically. Here we see the graph of the surface in blue. If we pause this square region here is the region of integration, this region here. If we look at this at the correct angle, we can see the surface is above the xy plane graphed here in yellow, above the region of integration, which should be in this region here. Let's zoom in on the region of integration. This gives us a much better view of the surface in blue and the region of integration. Again, the function is non-negative over this region, which means the double integral is going to give us the volume in this region here, the solid below the surface and above the xy plane over this square region. So going back to our example, let's first rewrite this. We first want to integrate with respect to x, but notice how we have this quantity raised to the third power, which means we'll have to perform u substitution. We'll let u be equal to 4x plus 5y. And now we need to find differential u, which is a derivative of 4x plus 5y with respect to x, treating y as a constant, and then times dx. So we'd have 4 times dx. If we divide both sides by 4, notice how we know that 1/4 du is equal to dx. So looking at the integral, if we focus on this part here, we can rewrite this as this would be u to the third, but then dx is equal to 1/4 du. Now we integrate. Notice with respect to u, we'd have 1/4 times u to the fourth divided by 4. In terms of x and y, though, we'd have 1/4 times u to the fourth is really the quantity 4x plus 5y to the fourth divided by 4. Now let's go ahead and rewrite this. Notice how we have a factor of 1/16. Let's write this as 1/16 times integral from 0 to 1. We'd be left with the quantity 4x plus 5y raised to the fourth, which we now need to evaluate at the limits of integration. These are limits of integration for x. These are limits of integration for x. So we'll substitute 1 for x, then 0 for x, then find the difference. So we'd have 1/16 times integral from 0 to 1 of, when x is 1, we would have the quantity 4 plus 5y raised to the fourth, minus, when x is 0, notice how we just have 5y to the fourth. Let's continue on the next slide. Let's write this as two separate integrals. We would have 1/16 times the integral from 0 to 1 of the quantity 4 plus 5y to the fourth, minus 1/16 times the integral from 0 to 1 of 5y to the fourth would be 625 y to the fourth. Notice how we do not need to perform u substitution to integrate here, but we do here. Since we already used u, let's go ahead and let v be equal to 4 plus 5y. Therefore, differential v would be equal to the derivative of 4 plus 5y with respect to y times differential y, which would be 5 dy, dividing both sides by 5. Notice how 1/5 dv is equal to dy. So in terms of v, this would be v to the fourth, and then dy again is 1/5 dv. So we integrate, we'd have 1/16 times, with respect to v, we'd have 1/5 times v to the fifth divided by 5, which means in terms of y, we'd have 1/5 times v to the fifth would actually be 4 plus 5y to the fifth divided by 5. Then here we have minus, let's factor out the 625, so we have 625 divided by 16. And if the integral of y to the fourth, we'd have y to the fifth divided by 5. Notice here, 16 times 5 is equal to 400, so we'd have 1/400th. And then we'd have the quantity 4 plus 5y to the fifth. Here, 16 times 5 is 80, so we have minus 625 divided by 80. And we just have y to the fifth here. Now performing substitution, we'd have 1/400. When y is 1, notice how we just have 4 plus 5 to the fifth, or 9 to the fifth. Minus, when y is 0, we just have 4 to the fifth. And then here we'd have 625 divided by 80 times, when y is 1, we have 1 to the fifth. When y is 0, we have 0 to the fifth. Well, 9 to the fifth minus 4 to the fifth is equal to 58,025. So we have 58,025 divided by 400 minus, here we just have 625 over 80 times 1, or just 625 divided by 80. And this difference here comes out to 549 fourths, which is the decimal is equal to 137.25. So here we have the exact value of the double integral, which again, going back to our graph, gives us the volume of the solid seen here below the blue surface above the xy plane over this square region. I hope you found this helpful.